Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving an interesting equation with complex numbers. If you're new to complex numbers, go ahead and check out my lecture videos. If you like algebra, number theory, and trigonometry problems, check out CyberMath, cyber with an S. Also consider becoming a member to support the channel just by clicking the join button. Okay, so we have this equation z ln z equals negative pi over 2. And you're probably thinking, are you serious? This is crazy. Okay, so if there's a will, there's a way, right? So let's go ahead and look at this problem from two different angles. First method. For my first method, I'm just gonna use the polar form of a complex number, which is because it's so compact, right? You can write any complex number as r times e to the I theta, where r is the modulus, which is the absolute value, and theta is the argument or the angle it makes. Now, of course, when you plot it, it'll be like a vector, right? Something like this, okay? That's my z. This is the theta. Of course, it has a direction. This is imaginary. This is real. And this is, the whole thing is called the argand plane. Let me spell it out so people think and there's no n there or d there, but there's a d at the end. Now, if you can write z like that, which is pretty compact, right? You can also find ln z because it's just natural log both sides. You're going to get ln r. Remember, r is greater than 0 all the time. So ln r is well defined, plus I theta. Of course, there are infinitely many values that theta can take because of the multi-valued nature of the argument. That's why ln z is not a single valued, okay? So, what does that mean? Well, first of all, that means that we can plug these into our equation, right? Let's do that. So multiply z by ln z and set it equal to the answer, which is negative pi over 2. How simple, right? Great. Now, this can be simplified, obviously. How? First of all, even though I told you that, yes, this is pretty compact version, but Euler's formula gives us another version of this. So e to the I theta can also be written as cosine theta plus I sine theta, which is awesome because this brings us the most beautiful equation, and we're going to use that right here. Okay, let's do that. So we get r times cosine theta plus I sine theta, which replaces e to the I theta from here. And then that is multiplied by ln r plus I theta, which is the natural log. And this is equal to negative pi over 2. Looks simple, right? Kind of. All right, let's go ahead and expand it. If you expand it, you're going to get an r all the way at the end. So, I mean, all the way on the outside. So let's go ahead and keep it outside for now. And if you distribute, you get cosine theta ln r. And then one thing that you need to keep in mind, and I forgot to say that, I always forget to say that. I times I is I squared, and I squared is equal to negative 1, because I is considered the square root of negative 1. Okay, that's how it's defined, but I squared equals negative 1 is a better way to remember that, hopefully. Now, when you distribute, you're going to get something like I theta cosine theta plus I ln r sine theta. These, and then finally I squared is minus 1 theta sine theta. Of course, everything is multiplied by r, and the whole thing is equal to negative pi over 2. Okay, great. Wow, what a mess, right? So what do you do with that? Well, first of all, you can go ahead and distribute and put the real and imaginary parts together. This is the real part, so you can kind of maybe keep the r on the outside. I don't know, that might be helpful. Cosine theta ln r minus theta sine theta. This is the real part. And then the imaginary part, of course, is still going to have an r because r is all the way on the outside. And you get theta cosine theta plus ln r multiplied by sine theta. And this is equal to negative pi over 2. Now, what is that supposed to mean? Two complex numbers being equal to each other. Well, it means that the real parts have to be equal. So first of all, this whole thing should equal negative pi over 2. How nice. And since there is no imaginary part on the right-hand side, because this is plus 0i, there's no I in it, so this whole thing should be 0. Make sense? Awesome. Now, maybe we'll start with the second one, right? Because the first one looks pretty messy, don't you think? Because how are you going to solve it? There are two variables, and it's pretty transcendental. Just a jumbo mambo. I don't think we're going to be able to solve it. So let's go ahead and focus on this one, because something equal to 0 is always better than something equal to a number, right? Just going to make sure our dot is raised. Okay, that represents multiplication, and this is equal to 0. What's that supposed to mean? Well, it means either r is equal to 0 or the other factor. But r cannot be 0. Why? Because if r is 0, that implies z is 0. Think of a complex number whose absolute value is 0. It's like 0 distance from 0. That's the only number 0, right? So you don't want that, because obviously it doesn't satisfy this equation, and ln z is not defined for z equals 0. It is defined for negative numbers, but not for 0. Okay, that's the only problem. So then we can safely say that this thing should equal 0. Good. We made some progress, hopefully. Theta cosine theta plus ln r multiplied by sine theta equals 0. And yes, it's still somewhat messy, but if you kind of think about it, maybe you'll come up with something. Let me not tell you at this point, because what I'm going to do is I'll probably, do the work, finish all the methods, and then come back here. Hopefully, we'll remember to come back here, put a little note, come back, okay? So let's go ahead and take a look, leave it at that point, and then look at the second method, because I think you're going to like the second method, but I could be wrong. Second method, again, we have z ln z equals negative pi over 2. I'm going to use a total different approach. You know what it is? It is basically the following. Z can be written as e to the power ln z, right? So this turns into ln z multiplied by e to the power ln z equals negative pi over 2. It doesn't matter where you write the negative. It still means the same thing. That's why I keep changing it. But wait a minute, take a look at this. We have something special thanks to Lambert's W function. So if you input t to the t, you're going to get t. Well, what does this have to do with our problem? Well, if you apply W on the left, you get something nice. Let's do it. Put a big W, take this as an input, and put another W, and take that as the other input. Now, why does this work? Because if x sub 1 equals x sub 2, and I'm just giving you the real version, but it also applies to complex numbers. If a function is well defined, then you can safely say that the outputs are going to be the same. In other words, if you have one input, it cannot generate two different outputs. Of course, we're talking about the real number set, but in this case, it might be a different story. But anyways, as soon as we apply Lambert to this is going to be our t, or if you want to call that coffee, that's fine too, but I'm going to call that t. So now this is going to be wt to the t, which is t, which is ln z. So from here we get ln z equals w of negative pi over 2. So then the million-dollar question is, what is w of negative pi over 2? Let me go ahead and show you. So negative pi over 2 can be written as negative 1 times pi over 2. Negative 1 can be written as I squared, and you might be asking, like, why would you replace negative 1 with I squared? Because I'm about to split it up into two pieces, and ta-da! This is really cool. You know why? Because if you think about I, ln I is I pi over 2. Why? Because remember the formula, ln r plus I theta. Well, the modulus for I is 1, so ln 1 is 0. So you end up with I theta, which is pi over 2, I times pi over 2. Make sense? So this is I, this is ln I. So how does that help though? Same idea. You're going to write it as ln I times e to the ln I, because I is e to the ln I. Of course, I'm assuming the principal value all the time. Of course, there are multiple branches, so on and so forth. But let's just avoid all these complications. This is my number. So I can go ahead and replace that with the thing on the right-hand side. ln z is equal to w of ln I times e to the power ln I. As you know from w's definition, this is equal to ln I. So ln z equals ln I, which hopefully means z equals I. Well, is that the only solution? That's a good question. That's for you to explore. But I'm going to go back as promised and show you how this plays out with the first method, right? We said that z is equal to I. Yes, okay, great. Now, let's go back here and take a look at this. Theta cosine theta plus ln r blah, 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 right? Let's go ahead and erase this area, clean up a little bit, all right? And then now we're going to go ahead and do this. We're going to look at this equation from a different perspective. We want it to be 0. How about setting both of them equal to 0? Obviously, theta isn't 0, right? We know that. How do we know that? I don't know. There's a chance that theta can be 0, but if theta is 0, sine theta would be 0, and this might work, right? So it looks like theta equals 0 seems to be a solution. Wait a minute. If theta is 0, then we get a real number, but the real number is not going to satisfy this, is it? Think about a real number like, I don't know, r maybe, okay? And a real number r. And if you plug it in here, it's not going to work because, why is that going to work though? It might, I don't know. Anyways, I got stuck. Let's go back here. So if theta is 0, we probably get a solution, which I don't know about. But if cosine theta is 0, that's a different story, which means theta could be pi over 2, in which case sine theta would be 1. Wait a minute, how can this be 0 then? Well, if r is 1, then ln 1 is 0, so this will work. Exactly, so this is what I'm talking about. R is 1, theta is pi over 2. Why? Because I want cosine to be 0, not theta to be 0. If theta is 0, then sine 0 becomes 1, and I don't know what happens. If you could probably solve it somehow. Well, wait, if theta is 0, then we're going to get ln r times sine 0, which is 0, equals 0. You see, from here, you're not going to be able to solve for r. That's the problem, because ln r doesn't even have to be 0. But these two give us what? Z equals r times 1 times e to the power I theta, and that's exactly I. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out Cyber Math and aplusbi, and bye-bye.